Hello everyone, welcome to Mathematics for Natural Science course. My name is Salam Mokra and I am a mathematics instructor with extensive experience of teaching different courses in college and university level. Now this course is designed for first year university students and aims to provide fundamental mathematical concepts that serve as a foundation for advanced mathematics and other science-related courses given at the university level. Now, the course consists of 4 units: the prepositional logic and set theory, the real and complex number system, functions, and analytic geometry. Now, in this video lesson, we will start chapter 1 by introducing prepositional logic. So let's get started. Okay, prepositional logic is a branch of mathematics that studies the principles of correct reasoning and valid argument. It uses symbols and formal rules to analyze a statement, to determine whether the statements are true or false, and draw logical conclusions from given assumptions. In general, it is a science of reasoning that provides the foundation for mathematics, computer science, even nowadays for artificial intelligence and many other scientific disciplines. So at this ground level, you are expected to understand what are the principles of correct reasoning and how to check whether a given argument is valid or invalid. So these are the main objectives of chapter 1. So having this in mind, just let's start from the definition of a preposition. A sentence is said to be a preposition or statement if and only if it is either true or false, but not both at the same time. Yes, at the first place, preposition is what? A sentence. Any sentence which can be said either true or false, but not both at the same time. So if you can say a sentence is either true or false, then it is a preposition, or we call it statement. So let's take example. Now, the first one, 4 is a prime number. This is a sentence, and we can say this sentence is false, because in order a number to be a prime number, the only factors are what? 1 and itself. But for number 4, the factors are 1, 2, and 4. Because of that, this sentence is what? False sentence. That means the sentence is what? A preposition, and the truth value of the preposition is what? False. Again, if we take 5 plus 8 is equals to 10, sentence which is what? False. So it is a preposition. In mathematical logic, we call such sentence a preposition or statement with truth value false. Again, if I take a square is a rectangle, it is a preposition. No question, it is what? A true preposition, because square is what? A rectangle. There is life on the moon. Yes, this is a little bit tricky. There is life on the moon. It is a sentence. For sure, no doubt it is a preposition. Because you can say this sentence is either true or what? False. So it is a preposition, no doubt. Now the question is it true or false? What do you think? There is life on the moon. It is a preposition. So what will be the truth value? Yes. True or false? Okay. Yes, for the time being, it is false, because we don't know for sure. For the time being, we don't know for sure whether there is life on the moon or not. So it is a preposition and the truth value is what? False. I wish I had an electric car. It is not a preposition because we cannot say it is true or false because it expresses what? Wish. If someone expresses his or her wishes, you cannot say you are correct or you are wrong. Similarly, we cannot say this sentence is either true or what? False. So it is not a preposition. And finally, let's take I hope today is Monday. If I say I hope, no one say you are correct or wrong. So I hope today is Monday, it is not a preposition because of I hope. But if I say today is Monday, it can be true or it can be what? False. But if you say I hope today is Monday, it is not what? A preposition. So let's take a key point. First, sentence that expresses wish, hope, feeling, attitude, command, or interrogation cannot be considered as a preposition because we cannot say such sentences are what? True or false. But a declarative sentence, it is a preposition because if someone declares, you have a possibility to say the sentence is what? Either true or what? False. So in general, when you have such sentence, we cannot consider as a preposition, but declarative sentences are what? Preposition. This is one key point you need to remember. And the other is we denote prepositions using small letters. Just the usual small letters are P, Q, R, S. Most of the time we use these small letters P, Q, R, S to represent a preposition or to represent a sentence which is either true or false. We use small letters. And also for any preposition, there are only two possible ways of assigning its truth value. Because any preposition is either what? True or what? False. So you may assign truth value true, denoted by T, or truth value false, denoted by what? Capital F. So these are the key points we need to remember. I hope you understand what do you mean by preposition or statement in mathematical logic. So let's take exercise. Yes, in exercise 1 up to 9, identify whether each of the following are prepositions or not. The first one, congratulations. Is it a preposition? There is a bluebird in Ethiopia. There is an even natural number. Addis Ababa is a city in Europe. Man is mortal. I wish I lived in London. And a parallelogram is a quadrilateral. 5 is a prime number. And the last, I will go to Japan by the end of the coming year. So try to check whether the given sentence are prepositions or not. Just take your time and check. Okay, I hope you get all correct. Now among these 9, all are prepositions except 1, 6, and 9. Just one, congratulations, it is not a preposition because you cannot say true or false. I wish I lived in London. Sentence expressing wish cannot be considered as a preposition. And the last one, I will go to Japan by the end of the coming year. It is not a preposition, but the remaining are what? Prepositions. Now the other concept we need is the logical connectives. In mathematical logic, we have 5 connectives. So you need to identify their names, symbol, and meanings. For each 5 connectives, you will have a name, symbol representing the connectives, and the meaning of the connectives. Let's see one by one. Now the first one is negation, which means not. And this one is the symbol to represent negation. Remember, negation means what? Not. The second one, conjunction, the symbol inverted V, and the meaning is and. Conjunction means and. The third, disjunction, is capital V, and the meaning is what? Or. And implication, just this symbol in logic represent implication, and the meaning is if then, the conditional statement. Now the fifth one is by implication. By means to implication, left to right and right to left, we have 2 implications, and the meaning is if and only if. So these are the 5 logical connectives in prepositional logic. Now when you combine 2 or more prepositions based on these connectives, the resulting statement, we call it complex or compound preposition. When 2 or more prepositions are combined by 1 or more prepositional connectives, the resulting statement, we call it what? Complex or compound. Now individual statement in a complex preposition, we call them component preposition. For example, if we take negation P implies P or Q, this is a good example of a compound preposition. Now in this compound preposition we have 2 components, PQ. So PQ, they are what? Component. PQ together with the prepositional connectives, negation, implication, and disjunction, the whole statement, we call it what? Complex or compound preposition. Now if a compound preposition has n component prepositions, then there are, to the power of n, different possible ways of combining their truth values. If a compound preposition has n number of component prepositions, in that case, to the power of n will be the different possible ways of combining the truth values of the component preposition. For example, here, this compound preposition has what? 2 component, PQ. Because of that, we expect what? To the power of 2, 4 possible logical combination regarding the truth values. Remember always, for a compound preposition having n component preposition, we expect to the power of n different possible logical possibilities in their truth values. So let's see the rules of the 5 logical connectives in logic. Now the first one is negation. Just the rule of negation. If P is true, the negation of P is false. And if P is false, the negation of P is true. Because negation means what? Not. So if P is true, the negation will be what? False. Not P will be false. If P is false, not P will be what? True. So we can construct truth table based on this rule. Truth table means a table that shows the possible logical combination in the truth value. So for negation P, we have only 1 preposition P. So for 1, how many possibilities? 2. Because if P is a preposition, it is a sentence either what? True or what? False. So for a single preposition, you have 2 options. It can be true or it can be what? False. So when P is true, the negation will be what? False. When P is false, the negation will be true. So this is a table that shows the logical possibilities for negation P. Now next to negation, conjunction. When two prepositions PQ are joined by conjunction, a logical conjunction P and Q is true if only if both prepositions are true, otherwise it is false. Now at the first place, when you combine two component preposition based on conjunction, the component preposition P and Q will have four logical possibilities. The combination will be 4. Both true, P true, Q true, P true, Q false, P false, Q true, or both are what? False. By the way, for two component preposition, the component preposition will have what? To the power of 2, 4 logical possibilities. Now to list these 4 logical possibilities, conceptually we have 4 factorial possible ways. That means you can write a table in 24 possible ways, but this one is the standard. The standard starts with P. Usually we start with P. So in the first column you put true, true, false, false. The second column Q, you write true, false, 4 times. Total you will have what? 4. Both true, P true, Q false, P false, Q true, or both false. This is always the way we construct truth table for a compound preposition having 2 component prepositions. So according to the rule of conjunction, yes, P and Q is true if and only if both PQ are true. Otherwise it is what? False. This is the rule. P and Q is true when both P true, Q true, true and true becomes true. Otherwise it is false. Otherwise this false means true and false is false, false and true, false, false and false, false. So this is the rule of conjunction. Now the third disjunction, the rule, when we combine 2 prepositions based on disjunction, P or Q, this will be false when both are false. Otherwise it is true. So the 4 possibilities, true, 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 false, false, true, false, false. Just by default we start with P, the first column, second Q, the second column. So P or Q, from the rule of disjunction, P or Q will be false when both are false. False or false is false. Otherwise it is what? True. Otherwise it is true means true or true is true. True or false is true. False or true is true. False or false is what? False. So this is the rule of disjunction. Now the false implication. Now P implies Q. A logical implication P implies Q is false when P is true and Q is false. This is a little bit tricky to remember the rule. When P true, Q false, true implies false is false, otherwise it is true. When you imply from true to false, true implies false is false in logic. Otherwise it is true. That means true implies true is true, false implies true is true, false implies false is also what? True. Later on we will see P is the hypothesis and Q is the conclusion. So when the hypothesis is true and the conclusion false, in logic true implies false is false, otherwise it is true. Like I said, for P implies Q, P is the hypothesis and Q is what? The conclusion. Or sometimes we say P is antecedent and Q is consequent. So when you imply from true hypothesis to false conclusion, True implies false will be false, otherwise it is true. Plus P implies Q will be equivalent to the following statements. P implies Q, the meaning is what? If P then Q. So if P then Q will have the same meaning with P implies Q. P only if Q means P implies Q. Q if P is also have the same meaning with P implies Q. In addition, P is sufficient for Q, or P is a sufficient condition for Q. We can also read P implies Q as what? P is sufficient for Q, or you can read P is a sufficient condition for Q. Similarly, you can read P implies Q as Q is necessary for P, or Q is a necessary condition for P. So all these 5 sentences have the same meaning with P implies Q. When you change symbolic form to verbal statement, you can use one of these 5 for implication. Now the fifth, by implication, just when you combine 2 prepositions, PQ based on by implication, a logical by implication, P if only if Q will be true when both have the same truth value. That means when both are true, true if only if true will be true, false if only false will be true, otherwise it is false. So as usual, the 4 logical possibilities, true, 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 false, false, true, false, false. So P by implies Q will be true when both have the same truth value. That means when both are true, it is true. When both are false, it is true. When they have different truth value, P if only if Q will be what? False. So this is the rule of by implication. By the way, by implication is the combination of conjunction and implication. Later on, we will see P if only if Q will be equivalent to P implies Q and Q implies P, because you have 2 implications. So it is the result of conjunction and implication. So according to the rule, when both have the same truth value, it will be true. Otherwise, it is what? False. And the other thing, by implication, P if only if Q have the same meaning with P if only if Q is based on verbal statement. P is a necessary and a sufficient condition for Q. This is also equivalent with P if only if Q. Q is a necessary and a sufficient condition for P. So in terms of verbal statement, you can use these 3 sentences to describe the symbolic form P if only if Q. I hope you remember the rules of the 5 logical connectives. It is important to remember each rule. Unless you have the rule of the 5 connectives in prepositional logic, you will have a difficulty to understand other concepts in the chapter. And the other point we need in this lesson is how we can construct truth table for a compound preposition. You remember we defined compound preposition to be what? When 2 or more prepositions are combined by 2 or more prepositional connectives, the resulting statement, we call it what? Compound or complex. So for a given compound preposition, you should know how to construct truth table at this level. So let's take example. The first one, negation P implies P and Q. So you have 2 component preposition in the compound PQ. So if a compound preposition has 2 component preposition, we expect how many logical combination based on their truth values? We expect what? 4. So first we list the 4 possibilities. It is composed of PQ, Just always the order is first we write P, then what? Q, in case we have two, PQ. So therefore, true, true, false, false in the first column, true, false on the second column. So these are the four. So after you list the four logical possibilities, for each logical connector, we will have one column. That means for negation, I will have one column for negation of P. For conjunction, I will have one column. And for implication, I will have what? One column. So let's start with negation P. So negation P means not P. So if P is true, negation P is false. P true means negation P is false. When P is false, the negation is true. Negation of false is what? True. So the third column, the negation of P, that is the opposite of what? The first column. So the third column is for what? The rule of negation. Now the first column, let's construct for P and Q. Inside the bracket, you have what? P and Q. So the rule of conjunction, when both are true, it will be true. Otherwise, it is what? False. That is the rule of conjunction. P and Q will be true when both are true. Otherwise, it is what? False. So the first column is for what? Conjunction. Now the last column for implication, that means we are going to imply from negation P to P and Q. From negation P, from the third column to what? The fourth column. We are going to imply. We combine the third and the fourth column based on implication. Now remember the rule of implication. So false implies true is what? True. The first possible combination. False implies true is what? True. False implies false. It is true. That is the rule of implication. True implies false. So whenever you imply from true assumption, hypothesis to false conclusion, in logic, true implies false is what? False. Again, true implies false is what? False. So this is the truth table for a compound preposition. Negation P implies P and Q. Now in exercise 1 up to 6, assuming P, Q, R are prepositions, you are required to construct a truth table for the given compound preposition. So 1 up to 6, try to construct a truth table. Now 7 up to 10, given the truth value of a compound preposition, you are required to find the truth value of a component preposition Q. You have the truth value of the compound. Based on the compound truth value, determine the truth value of the component preposition Q. For exercise 11 and 12, based on the given truth value, determine the truth value of the compound preposition. For example, for 11, if the truth value of P implies Q is false, what will be the truth value of the compound preposition R and negation Q implies Q implies P? So try to solve each of these exercises and make sure you complete all the 12 exercises here. So if you have any problem in solving, just take your time, revise the concept we discussed so far, and try to solve it. Practice again and again, because practice makes perfect. And unless you finish these 12 exercises, please don't start the second lesson. So see you. Goodbye.